Thank you everyone for attending this webinar. This is our Mastering Octopart webinar series. I am Zachariah Peterson, and this webinar is all about how to interpret data for your parts. And specifically, this is going to be about data sheets as well as what's not in data sheets. So here's our agenda. Of course, we want to run over what is in a data sheet, some of the important data that you won't find in data sheets, but that is out there from manufacturers and distributors. And one of the important things that comes up often both in data sheets and outside of data sheets is reference design data. So I want to run over that briefly. And then of course, we will run over where to get some of these data sheets as well as the other documentation that we're going to discuss in this webinar. So let's go ahead and get started. So first, what is in a data sheet? Now, most engineers, even new engineers, are pretty familiar with data sheets because these are going to be your first stop for technical specifications on a component that you're considering using. So we have technical specifications, both electrical and operating specifications, as well as some mechanical specifications. You also have things like operating data, which are generally based on either simulation or measurement. Obviously, measurement is much more common. Those operating data come in graphs, charts, tables, things like this. In some cases, with programmable components such as ASICs, such as processors, you have programming and usage guidance. And this is where you start to see divergence between what's in a data sheet and what's not in a data sheet. And for some components, you may even see PCB design guidelines. This could be something as simple as a footprint, and it could be something as complex as actual layout suggestions. We will discuss when you should use them and what to consider when looking at those guidelines. And then there are some other very important pieces of information regarding packaging, mark on the packaging, mechanicals, things like that, things that are needed both in assembly and inspection, as well as needed by other members of your product design team, such as a mechanical engineer. So first, what's in a data sheet? What's the basic information that you can expect from most data sheets? Well, here I've pulled a whole bunch of pieces of information from an HMC 624 component. This is a Hittite microwave component. Those of you that know me know I'm a fan of microwave. Previously bought by Analog Devices. And here are some of the important pieces of information that you're going to see, not just for these components, but pretty much for any ASIC. Functional block diagram that lists the pins, and you can kind of infer what the functions are for all those different pins. A summary of the features as shown in the lower left corner. Those features here are, of course, for an RF amplifier, so you can quite easily see that by reading through this list of features. Then absolute maximum ratings. These are, of course, important. They tell you when you're going to start stressing or overstressing the component. Sometimes you will also see safety information in the absolute maximum ratings. That's a little bit less common, but mostly this is just overstress limits. And then some basic specifications. Here in the previous slide, we showed some of the basic information like functional block diagrams, features, absolute maximum ratings, specifications. Here we have parameterized data in graphs. Most common is to parameterize it by temperature or by supply voltage. Another set of data you'll see here is, of course, alternative part numbers. These part numbers are generally delineated by package and temperature range. Here you'll also see one piece of environmental information, which is, of course, moisture sensitivity level. That MSL value is something that you won't find in environmental compliance statements. It is specific to the component. And then you'll also see things like branding and package options here. So the branding is, of course, important to ensure that the component you pulled out of a package is actually the component that you expect. So next, what's not in a data sheet? Well, one piece of information is product change notifications, or errata. The errata is sometimes called silicon errata. Application notes are not, of course, not a data sheet, but sometimes you will see some applications information in data sheets. So the applications information and application notes are actually quite different. You may see some programming or usage guidance. So this is more common for application processors. So these are ASICs that of course do some sort of processing or have to run an application. Or you may see these just in general purpose ASICs. You might also see these, or you will also see this with processors like microcontrollers, microprocessors, FPGAs. And then the environmental information such as conflict minerals, any other environmental information related to reach RoHS, that is also generally not contained in a data sheet. So first, let's look at some of the other important information related to mechanicals. So I'm showing here an example from a diodes Inc. component. You can see here that for the parts data that's available for this component, we have a data sheet and we have a technical drawing. Either of those could be used to get the package outline dimensions. And then here we also see a suggested pad layout. Now, this pad layout is just a suggestion, of course. It is based on whatever the manufacturer has done as far as assembly and testing. And the package outline dimensions are, of course, can be measured directly from the package, but those can be used by a mechanical engineer for any kind of 3D modeling that they need to do. Now, this suggested pad layout, which IPC standard does it correspond to? Well, we actually have no idea just by looking at this suggested pad layout. But if you're familiar with the IPC 7351 standards, you'll know that those standards use material conditions for calculating a pad size. So the material condition basically corresponds to the amount of solder in that solder joint that gets put onto that pad in order to bond the component to the PCB. So the IPC 7351 standard names 3 different material conditions, and those material conditions require different PCB footprints. And what that allows you to do is basically adjust the density of your pads in order to allow more dense assembly or less dense assembly if you need it. So here in the right-hand side of the screen, what I'm showing is a component that I've actually pulled from the manufacturer part search panel in Altium Designer. And this component actually includes all of those different IPC footprints. So you're not stuck with the standard pad footprint that's listed in the datasheet. There are other options. Now, there are formulas that I've shown here on screen for calculating that yourself just based on the material condition. Or if you get your parts data from a third-party source or you're getting it direct from Altium Designer, you may find additional footprints inside of that component. These footprints generally correspond to a different material condition in the IPC 7351 standard. Something else we commonly see in data sheets are application examples. So this is not necessarily a application note, but it is an application example, such as an example circuit. Here I'm showing just an example from the UCC 2113 isolated DC-DC converter. Here this can be used as a test circuit, but it is actually not the test circuit for specific applications. This is really just an example that you can use to play with to then work within your design. Here you are left to determine the values of these resistors. That's actually quite common. In other cases, they will show you a completely ready to use circuit in the data sheet that you can immediately build onto a breadboard or onto a test board. Now, along with these application examples, you will sometimes see PCB design guidelines. So I think it's very important to take a look at the PCB design guidelines and actually understand what it is they are showing you. Now, the PCB design guidelines that you see in a datasheet could be the evaluation product that they sell off the shelf. So evaluation products are very useful because, of course, they let you experiment with different components. But the PCB design guidelines that they're showing you might just be the evaluation product. And that's exactly what's going on here with this, the UCC component that we showed earlier from Texas Instruments. This is a screenshot directly from their datasheet showing the layout example. Now, the question you have to ask yourself is, does this layout correspond to what I can do in my PCB layout, and is it going to give me the operational performance I need? So that's something where you have to be a bit more knowledgeable about what's going on in the circuit that they show. And if you just look back here at the application example, you can see that all that they're doing in their design is basically driving a transistor. So if your design needs to do something else, then these PCB design guidelines might not be for you. This is actually really common with power products because then you'll see the manufacturers start putting ferrites everywhere, and then you have to ask yourself, do I actually need those components? And you can find many other examples when you start looking through the universe of power management ICs and ASICs. The other thing that you'll see commonly is a test circuit. So this is not the same as an application example. This is just a circuit for testing whether or not the component is performing one of its core functions. This is, again, an example for the UCC component that I presented earlier. And you can see here that they're showing some expected data as well as the test circuit that you would wire up and the procedure for running this test circuit. Next, something that's very important for lifecycle management is change notifications. And if you're dealing with processors or ASICs, silicon revisions. So most data sheets do not contain product change notifications, and they don't contain any information on silicon revisions. So just like a PCB, silicon also goes through different revisions. Maybe they discover something is wrong with the silicon, or they want to just slightly modify a feature. The manufacturer will revise the silicon and will start producing that new version. Product change notifications are used to update distributors about changes to a product. And so you can see here, I'm showing an example from Texas Instruments that was sent over to Mauser. And basically what they look like is the first page is like a cover letter like you see here, and then they go into some technical information as far as what exactly changed in the product. So if you're looking for these PCNs, you could contact the manufacturer, but some distributors also provide these PCNs for download. Silicon revisions, as I mentioned, the manufacturer does periodically update silicon for some components. Here you can see a table of the different revisions of the silicon for an AM1808 from Texas Instruments. Now, this is very important because if you're buying from a broker, it's very important to learn how to identify an old revision. Now, that could be very important because there could be a feature that was actually removed between two revisions of a device. So if you're expecting a device that has a feature and you get a different version of the silicon, you might not have that feature in it. And you need to learn to be able to identify that when you're buying from a broker. So they put the information as far as what is the silicon revision on the packaging. And this drawing in the lower half of the screen is showing you the markings on the packaging that denote the silicon revision. So silicon revision information can generally be obtained from the manufacturer of the component. Distributors generally don't hold this information. This is something that you will need to look up when you're selecting a component, especially a high value component like a critical ASIC or a processor. Next, we get to the fun stuff. Microcontrollers, microprocessors, FPGAs, those types of components. So these data sheets are huge. They can be hundreds of pages long. They contain huge amounts of information such as register functions, pin descriptions, some guidance on pin and interface usage. If you're looking through a data sheet for any of these components, you'll see tons of graphs showing timing requirements. You'll see a lot of information on feature description, and you'll see a little bit of programming guidance. Unfortunately, if you look in a data sheet, the programming guidance tends to be pretty minimal. If you start to look up the documentation on a processor, such as the MSP430 that I'm showing here, you'll see that the technical documentation is pretty extensive. And there are a lot of different application notes, as you can see here on screen. Some of these application notes refer specifically to programming. So you can see right here, for example, we have a programming a flash-based MSP430 using JTAG. And so on and so forth. And in total, you can see that there's 37 pieces of documentation needed to use this component successfully. Only one of those pieces of documentation is the data sheet, and another one is the silicon errata, as you can see in the second entry in this table. Now, what other pieces of information do you need? Of course, there are pieces of software that are used to program certain components. Texas Instruments is really great about this because they will release their software development kits, and they even release example code. So if you are considering using a new processor, look up and see if you can find some example code for it direct from the manufacturer, as you can see here on screen for the MSP 430. Not all microcontrollers or processors will have that those code or application examples available. It all depends on the vendor, but for me, that's actually a really big factor in determining whether or not I go with a specific processor in a project. You might also have to get a programmer or a debugger. If you don't have a serial interface coming off of a computer, you would then need to use the vendor's programmer and debugger in order to flash your board and then get your application program onto your test board and then run it on your board. Some other data that's not found in datasheets, of course, the firmware. So one pair of components that I use a lot for lower speed networking equipment is VSC 742X and then VSC 8000 series expansion PHYs. These are Vitesse components. They are actually available now from Microchip, since Microchip purchased Vitesse. And here, one of the important pieces of information is the programming guide. So the programming guide, again, not found in the datasheet. It's actually its own document. And this particular programming guide actually requires registering with the manufacturer on their website. So if you go to their registration portal, you may have to fill out and sign an NDA. You'll have to go through and click through some terms of service. They will make this available to you behind a password. So it's not something that you can just download from the product page. But once you get there, you'll be able to get this this guide, which will then help you, of course, set up your board and gives you the instructions for going through and doing some initial debugging and power on testing, and then flashing your application onto the board. Now, the firmware binaries, obviously not part of a data sheet, but these are binaries that you would need in order to start using this pair of components together. So some manufacturers are making all of that information available from GitHub. Sometimes you need to register for their support area, and you can get it again in the same area that you might get a programming guide. In some cases, it exists, but they don't make it available to you even under registration. What you actually have to do is contact their support team and then get it under a license or under an NDA with an eval board. Here for these two groups of components, you can see here I have several pieces of firmware, or several different versions of this firmware that are available depending on the memory chip that's being used in this product. And then you can see here I have a folder for additional firmware that we didn't even test. So there's a lot of different firmware options that can help you get started with these components, but you'll need the programming guide, and you'll need to probably go direct to the manufacturer to get this information if it's not available publicly on the product page or from GitHub. So where can you get parts documentation? Of course, distributor websites carry some of it. I mentioned parts change notifications earlier. The manufacturer website is one great place to get a lot of the stuff that's not in a data sheet. But for the data that you need, that's really the workhorse of what you need to do for design, Octopart search data contains a lot of that information, especially data sheets. And Octopart is, of course, my go-to to finding data sheets for parts. When you need to get a data sheet, when you're on Octopart, going through in the specification view, you can of course see right here in this column, we have an entry right there for the data sheet, and it contains all the information that we need for the components in these search results. Data sheets can also be accessed on the parts pages. And when you look on parts pages, you will see some other important pieces of information, such as reference designs. So if there are reference designs available for different components, you can see that directly on a parts page, and then you can click over to the manufacturer website to get downloads for all of those reference designs, as well as eval products and things like that. Another thing that you will see on parts pages is additional environmental information. For example, is it lead-free? Is it REACH or RoHS compliant? Here, another example, is it radiation hardened? And then these compliance statements are also available directly on Octopart, both RoHS and REACH statements, as well as conflict mineral statements. If you are trying to make sure that you are lead-free, you can see lead-free and then REACH and radiation hardening and RoHS data directly in the search results view when you're searching for components. So I'm going to hand it back over to my colleague, Adrienne, and we will continue.
Thank you. All right. So join us for our second webinar in the Octopart Edge series on May 23rd as we explore the intricate world of REACH and RoHS and compliance regulations with the electronics industry. Again, led by Zach Peterson, this session will equip you with essential insights and practical strategies to effectively navigate these complex regulations to ensure your product meets global standards. You can register this webinar on the email that will be sent for our on-demand for today's webinar. You should be getting that in the next few days. And next is questions. All right, so we have a few questions here. The first question is there a way to subscribe to product change notifications, or do I need to look those up when searching for a new component?
Yeah, that's a great question. So you should contact the manufacturer because the manufacturer is the one who sends all of that stuff out. So they're really the source for product change notifications. As far as product change notifications, which ones should you get? You don't need to subscribe to every single product change notifications. I would say if you have a product in the field and you want to make sure that you are up to date on product changes to the main components in that product that you have in the field, then you should contact the manufacturer and see if you can get added to their list to receive product change notifications. Because otherwise you're going to be manually looking it up periodically, for example, from Mouser or wherever else you order components.
Great. And the next question is for processors, is there a standard document for documenting the code or application examples?
Yeah, that's a great question. I wish there was. You kind of have to rely on the commentary in the code, unfortunately. So the programming guide may have some information on that, but the reality is that if they're releasing the code for an application example, most of that commentary is actually going to be in the code itself.
Great. Looks like that is all of our questions for today.
Okay.
All right.
Thank you, everybody. Oh, sorry, go ahead.
I was going to say thank you, everyone. Thanks for holding out for our technical difficulties. And thank you so much, Zach, for presenting today. It's super informative. And yeah, until next time, we look forward to having you guys on for our next webinar for next month.
Thanks, everyone.